much for the invitation to participate in this workshop, which I find hugely interesting. And I want to go over to a bit of a different topic. So basically to the use of naturalistic viewing for phenotype prediction. So which basically means that instead of what a lot of studies have done using resting state to predict phenotypes, there's now more and more studies using movies. So basically movie clips in the scanner with the expectation that these movie clips or this more naturalistic stimulation might improve phenotype prediction. And I wanted to quickly start with this figure that from Emily Finn's paper, which I really, really like to explain basically the considerations when using different brain states to predict whatever phenotype we want to predict. So basically what we have is in the middle, the ground truth, so 3 different individuals. And whenever we are talking about predicting individual differences or identifying subjects, so basically intuitively one would think to try to make subjects more different from each other while also preserving their key features. But that might not necessarily always be the case. So in this example that Emily created, or in this representation, we look at how to make subjects more identifiable or more similar. And like in the lower left quadrant, one way to modify these images is to completely scramble them, which makes them less similar, but also less identifiable. So basically probably not very useful for predicting any individual differences. Also in the lower right corner, where the images are blurred, basically destroying all the features makes the 3 example subjects here more similar to each other, but also less identifiable. But then if we go to the top of the figure, we can see on the left, one way of making subjects or individuals more identifiable is to specifically bring out, like in a caricature, the most prominent features. That at the same time makes them less similar. Or we could choose another way where we actually make subjects more similar by getting rid of background variations that we're not really interested in, but at the same time preserving the key features of the subjects. And when we relate this to functional brain imaging, the lower right quadrant would be something like a task approach, where we have a very tightly controlled task condition, which makes participants very, very similar, and is therefore probably not that ideal for looking at individual differences. Also, of course, also individual differences have been examined using tasks. On the other hand, the upper left would basically be our resting state approach, which, because it's so free in leaving subjects a way to think whatever they want to, with no task restrictions and no instructions, basically they can bring out their key features to a very large extent, which might be very useful for the individual difference prediction. And the upper right would be our movie approach, which has the advantage that through showing the movies, we have a controlled task condition in a way, so we make subjects more similar. But at the same time, every participant, every subject will react hopefully different to the movies. In that case, bringing out, while making subjects more similar, making them also more identifiable. But I think to this point, there's more and more studies comparing resting state to movies in identifying individual differences. But it's not really solved which one is actually better, and there's a lot of factors to consider. And what I would just like to show, bring up for discussion, is some ways how we currently trying to access what these movies do to the brain state of the participant. And this, what you see here is a very simple display where we had 4 different conditions, so resting state and 3 different movies, repeated over 3 different sessions within 1 week. And what we've done here, we basically looked at what's called representational distance matrices by looking at how similar or how different does this movie or this resting state task make all the subjects in our group. So we have basically a matrix of subjects by a subject showing how different each subject is to each other within these specific condition. And then we can use dimensionality reduction to bring this complex matrix into a lower dimensional space, two-dimensional space, to preserving the neighborhoods. And then we can see basically that resting state indeed, so the blue is resting state over the three sessions, indeed resting state, at least in these networks that we're looking at, seems to be very different from the movies. So it's clearly distinct from the movies. Or in other networks, resting state might cluster together with the Inscape movie, which is a very abstract movie that doesn't really have a storyline, but rather only shows moving shapes. So it does seem that something is indeed different between resting state and movies. And interestingly, what we also see here, that the session effect is not very strong. So in principle, we could have also had a result where all the squares or the session 3 cluster together, or the crosses, but it seems to be that actually the content of the session is what makes people, or what has the same impact on people. It's not a session effect. Different way of looking at a similar thing is basically, again, within each of the triangles is one meta-analytical network, and all the lines and rows are different movies and two resting state conditions. So R1 and R2 is resting state, others are different movies. And what we see here is a measure of how different people are from, or how different the different conditions are from each other. And again, we see that resting state sticks out. So the difference from resting state to the movies is much bigger than between the movies themselves. So it might not even make such a big difference what kind of movies we're showing. It still makes people different from the resting state. And that makes a lot of sense in the empathy network, because at least intuitively, one would expect that there's much more going on in terms of empathy when you watch a movie with a storyline than when you're just lying in the scanner. But we see the same effect also in the emotion regulation network, again, resting state being different from the other movies. And then another, this is an example where we predicted sex from movie watching across 4 different movies from the Human Connectonome project. And the interesting thing we find here, this is an example, we see that also in other examples, is that the accuracy of the sex classification is related, or appears to be related, is not statistically tested yet, appears to related to the length of the movie. So at least with a short movie, it appears that it's not that much the content of the movie that enables better sex classification, but rather the length of the movie. So the longest of these short movies achieved the best sex classification accuracy. And finally, another example where we again used HCP data from 3 different movies and 4 different tasks to compare prediction of different phenotypes from movies versus task. And basically what we see here is it depends. So it depends on what kind of feature, what kind of phenotype we want to predict, which of the brain states or the conditions performs best. So for openness, for personality, and for working memory, it appears to be the movie. For fluid intelligence, it's language, and for emotional recognition, it's a social task. So basically, the whole conclusion so far from this is it depends very much on what we want to predict, what movie we're using, and maybe an interaction of both. And this is what I wanted to show, and I really wanted to, I hope that there will be a discussion of many open questions that are still with using these movies for phenotype prediction. So what are the effects on functional brain connectivity? What are the effects of identifiability on the brain behavior relationship itself? And importantly, lots of papers are talking about movies, but what movies specifically? So how do we choose a movie that enables a good prediction or classification? Is it the length? Is it the contents? which features of the movies are relevant, and is there maybe even a subject by content interaction, in the sense that for specific subjects would other movies be good than for other subjects? So a lot of open questions, which I'm hoping that we can address a bit here in the discussion. Yeah, thanks a lot for all the group members who contributed to this in one way or another.